Hello, everyone. My name is Rich Harris, and this talk is called Remote Control for reasons that will soon become apparent. I'm here representing the Svelte team. For those of you who aren't familiar, Svelte is a declarative component framework, similar in spirit to React and Vue and Solid and things of that nature, albeit with a few philosophical differences. In addition to Svelte itself, we maintain a full-stack application framework called SvelteKit, which is our vision for what building robust, accessible web apps should feel like. It is an incomplete vision. There is a lot of work still to do, and some of that work is what I'm here to talk about today. If you haven't tried Svelte before, you should. It's a project that many of your fellow developers are very excited about. In the State of JavaScript survey, we were the most interesting framework for the last 6 years running. But very few projects have garnered more developer love than Vite. And part of the reason that I'm so excited to be speaking at ViteConf is that SvelteKit and Vite have a long shared history. We were the first meta framework to adopt Vite when it hit version 2. And we wrote the server-side module loader, which is necessary for server-side rendering, that was adopted in Vite as the SSR load module API. We have overlapping teams. There are many people who contribute to both Vite and Svelte. We're invested in each other's success. But in a way, my personal history with Vite goes back much further, back, in fact, to before Vite existed. 10 years ago, I started a project called Rollup, which some of you have probably heard of. It is the module bundler that Vite uses internally to produce your production build. Back then, it had a singular focus, which was building libraries. You would author your code in native JavaScript modules, and Rollup would bundle them into a script that could run in Node or in the browser, because back then, you couldn't run modules natively. It didn't know about CommonJS or TypeScript or anything like that. It just knew about JavaScript. You could at least specify a transform array. Most notably, back then, we would use Babel to transform our cutting-edge ES6 code with arrow functions and class declarations to the ES5 code that actually ran in browsers. Some of you might have missed that era, and I deeply envy you. So in addition to Rollup, I maintained a project called Rollup Babel, which basically just augmented Rollup with the configuration needed to convert ES6 to ES5. And after a while, I thought, everyone wants this functionality. Shouldn't it be the default? And so 10 years ago, almost to the day, I proposed just that. And Oscar Seyersved, aka Victory Stick, one of the key early contributors, said, counterpoint, no. He proposed the creation of a plugin API instead. And so that is how, a decade ago, the Rollup plugin API came to be. I often get credit for it, and I shouldn't because it was not my idea. In my defense, I am not the only developer who didn't initially understand the value of plugins. But I'm glad I came around because plugins are what makes Rollup and by extension Vite so powerful. Like most white guys, I spend a lot of time thinking about the Roman Empire. Specifically, I think about the width of Roman war chariots, like the one Charlton Heston rode in Ben-Hur, which were made just wide enough to accommodate the back ends of 2 horses side by side. Now, those chariots caused ruts in the road, which meant that everyone else either had to kind of build their own chariots to the same dimensions, or they would always be breaking down. Many centuries later, when the English started building railways, they used the same tools they had used for building wagons, which meant that railways adopted the same standard width, 4 feet, 8.5 inches. This is the Stockton and Darlington Railway, the first ever passenger rail service, which opened exactly 200 years ago. When the American railways were built, they naturally did the same thing. And so when engineers on the space shuttle program were designing the solid rocket boosters, the 2 things either side of it, which had to be transported by rail, they had to work to the same dimensions. So a major design feature of what is arguably the world's most advanced transportation system was originally determined by the width of a horse's ass. The motto of the story is, specifications and bureaucracies live forever. Or as the ancient Roman philosopher Maximus Decimus Meridius phrased it as he addressed his troops, what we do in life echoes in eternity. As a former journalist, I am obliged to tell you that the space shuttle story is almost certainly complete bollocks, but it does illustrate the point quite nicely. I think about this stuff because Vite is in the process of moving to roll down, which, as you all know, is a Rust-based successor to roll up. But because there's so much code out there that uses the Rollup plugin API, Rolldown has to match that API. So let's talk about what you can do with it, using some examples from SvelteKit. Because when you get right down to it, SvelteKit is basically just a collection of Vite plugins. One of those plugins gives you access to virtual modules, such as the $Env family of modules. These give you access to your environment variables. We've got static modules, which are known at build time, which lets you do things like dead code elimination, and dynamic modules, which are known at runtime. And then we've got private environment variables, which can't be exposed to client-side code because they contain things like database credentials that you don't want to leak. For this, we use the load hook of the plugin API, which lets us return some generated code for a given module ID. I mentioned that it's unsafe to use private environment variables outside the server, and the way that we enforce that is with another plugin, the guard plugin. This runs in 2 stages. First, we use the resolve ID hook, but not the way that it's meant to be used. You're supposed to use it to resolve an import to a canonical module ID. But here, we're not actually returning anything. We're just inserting ourselves before other plugins using enforce pre so that we can observe which modules are importing which other modules. With that information, we can use the load hook to know when server-only code is being imported by a module that could run in the browser. Again, we're not actually loading anything. We're just abusing this hook to know when something is loaded that it shouldn't be, so that we can give you a useful error that tells you exactly how to fix it. We also use the plugin API for feature detection. If you have a SvelteKit app, you can deploy it wherever JavaScript runs, but not every environment supports every feature. For example, there's a function called read that lets you read assets from the file system, but you can't do that if you don't have a file system. So inside the read function, we call __ SvelteKit _track __, more colloquially known as SvelteKit track. During development, it is a real function on global this. And when it gets called, we figure out which route we're currently handling using async local storage, figure out where that route is going to be deployed, and then throw an error if the feature won't be supported. But you might not hit that code during development, so you also need a way to detect the use of unsupported features with static analysis. And for that, we use the render chunk hook of the plugin API. Any calls to SvelteKit track will be visible inside the code Vite generates, which means we can associate the feature with a specific route for later analysis, and then replace the function call with a harmless comment. Now with Vite, when you import a module, it will also start importing everything that that module imports, transitively or otherwise, so that there are no waterfalls. It also means that if your module loads CSS, that CSS will be applied before the code runs, so you don't get a flash of unstyled content from something being added to the DOM before the styles are ready. But this only works in the browser. If you're rendering the content on the server, and the content depends on some CSS, Vite doesn't know about it. So in the dev server, we have to jump through some hoops. We create a function that traverses the module graph on the server, finds all the CSS imports, and then stitches them together so that the styles can be injected into the HTML. We do all this so that you're not left wondering, is this flash of unstyled content going to happen in production too? Excuse me. Finally, we use the write bundle hook to chain together several builds. First, Vite bundles the server code. That's the main build. Then once that's done, we load the code in a child process so that we can analyze it to see which routes need pre-rendering and so on. Then we use that information to create an optimized client build. Once we have that, we update the server build with information about which JS and CSS assets belong to which route. Then we pre-render whatever we can, which means generating static HTML files that can live on a CDN instead of users needing to hit your origin server each time. And after that, we can optimize the server a little bit more. Then we generate a service worker if you need one, and then we pass all of that stuff to your deployment adapter. So there's quite a lot going on, and we're definitely not using write bundle the way it's supposed to be used. And we've had some conversations with the Vite team where they were like, can you not? So hopefully once the environment API stabilizes, we'll be able to do all of this stuff a little bit more idiomatically. So as you can see, we're using a lot of the plugin API, and not always in the way that you're meant to. It is a real testament to Vite that all of this stuff is possible. But we're not done yet. A few months ago, we started work on our most monstrous abuse of the plugin API so far. It is a set of SvelteKit features we're calling remote functions. And I want to tell you how we built them. It's really more of a confession than anything. Forgive me, Evan, for we have sinned. But before we can do that, I should show you what they are. So you know what time it is. It is time for a controlled demo. I need to try and disable mirroring. Wish me luck. OK, enable mirroring. All right, so I have an app here with a button. And when I click this button, the counter goes up. All right, hold your applause. I'm cheating. This is just client-side state. Maybe if I make my screen a little bit bigger, you can see what I'm working on. Every time we click the button, this function runs, count plus equals 1, the DOM updates. Pretty straightforward stuff. But when I reload the page, my state is lost. All my hard work for nothing. So we want that state to live on the server instead. And I'm going to make that happen by creating a file which we call a remote module, count.remote.ts. Inside here, I will declare some state, let count equals 0. And then I'm going to expose a way for the client to get that state, something called a query. Export const get count equals query. And then I'm just going to return that value. And then inside here, all I need to do is replace the occurrences of click with, count with await get count. Get count, like that. Hit save, and you see it's pulling the 0 from the server. Now, some of you will be looking at that code and be like, Rich, you've got an await after an await. Like you're going to go and get the count, bring it back from the server, and then you're going to go again to get the same data? Like, do you not know anything about how JavaScript works? I always thought you're a bit of a muppet, and now I have proof. Firstly, rude. Secondly, that's actually not how it works in Svelte, because everything inside the template we know is a pure expression, which means that we can run those two awaits concurrently, automatically. We can do the promise.all stuff on your behalf, because that is what computers are for, doing menial tasks that we shouldn't have to think about. And secondly, even if it didn't work that way, it's actually okay in this specific case because getCount refers to the same thing in both cases. So Svelte is smart enough to cache it for as long as it's being used. Anytime you have getCount used anywhere on the page, it will refer to the same instance. Of course, when I push the button, nothing happens because we're not writing the data back to the server. So let's wire it up. Down here, I'm going to add the opposite of a query, which is a command. Increment equals command. And I would like to be able to pass a number into increment by. When you're passing data from the client to the server, you need to be pretty careful about validating it because you might have a different version. The client might have an old version and the server has a new version. Or you might have people who are probing the endpoints of your application for weaknesses so that they can mine Bitcoin. So it's very important that you always validate your data. So I'm going to add, first I'm going to import a validation library. Import v from valibot. You can use Zod, you can use valibot, archetype, whatever, as long as it implements the standard schema convention. And then the first argument to command is going to be a v.number, like that. And now d inside inside this handler is a number, so count plus equals d. And now, if I reload the page, still nothing happens, but at least when I refresh the page, oh, it would help if I called the function, wouldn't it? Live demos. When I reload the page, it's not validating because I forgot to pass the number. The system is working as intended, ladies and gentlemen. Press the button, and the state has been persisted to the server. We can get rid of our local client-side state. That's no longer being used. But we do need to tell the page that something has changed. So inside the command, we're just going to link it to the query with getCount.refresh. And now when we push the button, the data comes back. And what's interesting is if we look at the network tab and press the button, you see that it's only making a single request. We're calling increment, and then the result includes the queries that have been updated as a result of running that command. So it's a single flight mutation, much more efficient than if we were going back and forth. So this is all well and good, and the ideal demo conditions, the server is on the same machine as the client. In real life, you have network latency to deal with, which you can simulate by making this an async function and adding await sleep. Now when I push the button, nothing happens for a full second, which is a little bit dissatisfying. We could fix that in a couple of ways. We could use the increment.await pending property to define some slightly different UI. But a better thing to do in this case would be to have an optimistic update, because we kind of know what state to expect back from the server. We're just incrementing a number, right? So in this case, we can say increment updates get count, and then we'll provide an override that takes the current state and returns the updated state. And now, when I press the button, it updates immediately, even though the requests are still in flight. And if something were to go wrong in here, math.random 0.5, throw a new error. Oops. Anything that doesn't succeed will just get rolled back automatically. So it's nice and robust. All right, that's my button demo. How am I doing for time? Oh, not well. I have another demo. It's a weather app, and it's apparently not working. Yikes. This is what happens when you rely on an external API in a live demo. So in this weather app, I have a bunch of different cities with some summaries, and the first one is expanded. And if I look at how that's implemented, we can see that I have this await get current weather city. It's a query for each city, and then if it's expanded, then we call this get forecast function as well. So it's calling that each time. Now, you'll notice when I load the page, it's not doing any fetch requests, because when it renders on the server, the data gets sent to the client along with the markup. So we're not having to do that every time we start the application. But if I open Paris, it makes a request. And then if I click Show All, it makes 3 more requests for the remaining cities. That's not totally ideal. At this point, you might think, well, this is why you use React server components, isn't it? Because that way, all of the data loading always happens on the server. And whenever something updates, you just go back to the server and it re-renders everything. And maybe that way we could figure out how to do the batching and send it all back in one go. And you could, but then you have another problem, which is that you have some client-side state, like you're toggling between Celsius and Fahrenheit, and you need to figure out the rules about how you can combine client-side state with server components, like do I pass it through like this or like that? It's very confusing. I can't figure it out. I know a lot of other people can't either. So we reject the React server component model. We actually think there's a really good reason that model and view are traditionally separated. And so we have a slightly different approach to this problem. Get forecast, I'm going to turn this into a batched query. Like so. Instead of sending an individual city, we're going to get all of the cities, send those all to the API. We're not going to destructure anymore. And instead of returning the data, we're going to return a function that returns the data. Like that. And so now when I load this page, if I click Show All, it's going to get everything in a single request, so we can have the best of both worlds. It's all a client-side application, but the data can be fetched in the most efficient manner. All right, I have one more demo that I'm going to try and speed through. You've all seen a to-do app, right? But have you seen the sequel? No, that's not good. PNPM dev. Oh, wow. There we go. OK. To do. But before I get into this, who here works with forms as part of their job as a web developer? Who here likes working with forms as part of their job as a web developer? A lot of fewer hands went up. Yeah, forms kind of suck. I've got a form here. It's going to let me log in. If I send some bad data, it's going to validate it. All right, let's have a look at what's going on here. So if I bring open this module, you can see that I'm spreading this login object onto the form. That contains the method and the action and some event handlers and so on. And if we look at that, this is another remote function. In my opinion, the crown jewels of the suite of remote functions. Like before, we are passing in a schema to validate that the data we're getting is valid. And then we have a function that runs once the valid data has gone through that barrier. And you can see that it's telling me the password is too short because there's a minimum length of 5. So if I put in the correct password, I can log in. And you notice that in fact, maybe if I just go back to where we were, The form itself has an input where I'm spreading the input, the email field onto the input, and that provides us with all of the attributes that we need: the name, the type, aria invalid, which a lot of form libraries forget, and the value, all done for you. If you had to do all of this manually, including wiring it up, it would be a lot of code. So this makes it much easier. And the aria invalid we're using as a CSS selector, so you can see that slight red glow, that's because of that. And then below it, we just have a live view of all of the validation issues. Okay, so in the form, I'm going to create some to-dos real quick. I'll create a low priority one and then a high priority one. If we look at this range input here, you'll see that the create to-do form has a slightly more complex schema. We have a nested object with a numeric value inside it. And because it's a numeric value, it will only let us declare it as a range or a number. So you get really good type safety with this solution that's a little bit harder to do in some other ways. And if I put that to something else, I'm going to get a red squiggly. So we'll leave it as it was. And obviously, I can sort this by priority or created and so on. What happens if I try and toggle the complete state of one of these to-dos? Well, again, it's taking its sweet time. And if we look at the implementation of this, we'll see it's coming from toggle, which has one of those await sleeps again. Ah, silly as. Well, we could fix it on the back end by removing that, but let's fix it on the front end instead by taking our form object and enhancing it with some client-side behavior. So just like with a command, we can say what it updates. We're going to take the to-dos array, I'm going to map over it. And in most cases, we're going to just return it as is. But if the to-do ID is the one that we currently care about, then we'll return a copy, like so. And so now we have fully optimistic updates. If you look at the network tab, you can see that that's all going through. And when it comes back, the override is removed. OK, so you get really good interaction, feedback, and so on, with also really good robustness and type safety. All right, I'm not going to make it all the way through. Does this mean forms are fun now? No, it does not. Forms will never be fun, but at least now you can spend a little bit less time building the damn things. We do have some unsolved problems around caching and automatic refreshing, syncing between tabs. We have some real-time designs that we're very excited about. All very solvable stuff that we just haven't really got around to yet. So how does it work? Well, this is the part that I don't really have time for. It is another really twisted Vite plugin API hack. Instead of transforming the code using static analysis, we are, when we get a request inside the transform hook for a client module, instead of doing something with the code, like analyzing it and then seeing what gets exported and then sending it back, we have to actually load the module on the server so that we can analyze the code that is, not the code that's being exported, but the actual objects that are being generated. Which is not something that you're really supposed to do in a transform hook, but it works really well. I'm going to have to just skip over the rest of it. So on the server, we basically just return the module as is, but we append some code that lets us assign a special ID to each remote function so that we can create an endpoint for each of those so that the client has something to hit. And we also add a $$ export call at the end so that we can extract that in the subsequent bundling process and turn that into an entry point that the server can reason about. Never mind this, never mind that. I have 27 seconds left. So I'm really happy that when we started building remote functions, we didn't know how hard it was going to be, because we had a lot of false starts and dead ends. But the thing about Vite is it always gives you a way out. And if you've been building apps with Vite, but you haven't really used the plugin API, I highly recommend it. It is very empowering. I think remote functions are empowering too. For a long time, Svelte has been seen as a framework that's really fast at doing updates in the browser, but we're now starting to explore what it would mean to be the best full-stack framework possible. I am really excited that we'll be able to build on top of this foundation, better ways of thinking about storage, about auth, about internationalization, everything that goes with it. So be a power user, and remember, what we do in life echoes in eternity. Thank you.